Hey everyone, today we are back to working on the Ryobi RM480e mower, and unfortunately it looks like I need to replace the motor drive controller. So in a previous video I showed you I put the LIFE-P04 batteries in it, and also, if you may have noticed in that video, I had trouble getting it to move the very first time I tried it, and I thought it was just because of the position I had the switch, the forward neutral reverse switch in when I turned the mower on, but it seemed like a power off, power on solved that. So I used the mower, I cut my lawn with it the first time, it worked fine. It struggled a bit in the tall grass, but it mowed as I expected it to. Then I used it a few times actually after that, since towing a cart, pulling some barrels of dirt around the yard, and on the last time I used it, what happened was I drove it into the backyard. I unloaded my cart full of dirt. I had left the mower on when I got off of it, in the on position, so the unit was beeping to let me know that I had gotten off the mower while it was still turned on. I sat back down on the mower, pressed the gas pedal, and the whole thing went dead. Just completely dead. So I turned the switch off, turned the switch back on again, and nothing. So I'm like, okay, let me disconnect the battery and plug it back in. So I disconnected the battery, reconnected it, and the power came back on. In that particular case, I think I tripped the BMS. That's the battery management system, and that's built into the batteries. So I tried to move again, wouldn't move. But what was different in this case from the first time is, even if I put the mower in reverse, it would not beep. It would not move, it wouldn't move in forward or reverse, but it wouldn't even beep when I put the switch in the reverse position. Another thing was, it seemed like the motor was engaged, because the thing wouldn't push. So right now I have everything disconnected, and I'm going to show you how I determined the motor control is bad for certain on this particular unit. I'm really bummed because I already spent $700 on this mower for the new batteries and the new charger, and the replacement module here is going to cost me another $300. So this free mower is going to cost me about $1,000 at this point. So but let me show you some tips and tricks I've learned and how I determined that this motor controller is bad. So there is a Facebook group that is a community of people who own these mowers, and it's full of amazing tips and information on this mower. So definitely encourage you to go check that out if you haven't already. But basically, several posts and things I found online have pointed to a bad motor controller for these symptoms. So I am going to run through the tests that and show you some tips and tricks about how to remove this that I couldn't find online myself. So let's start with removing the motor controller. So this mounts up here on the side of the mower, kind of like so. In order to remove this, you are going to need to remove the battery pack, and you're going to need to remove the left side of the mower. For that, you're going to need a ratchet and a T30 bit. I tried using a screwdriver T30 bit, and those bolts were on way too tight even for me to get them off without a ratchet, so definitely going to need that. And you're going to need a utility knife to remove the shrink wrap, and of course you're going to need a 13 millimeter socket on a long extension to remove the battery bolt in the center, and 1/2 inch socket and wrench to remove the back side of the battery mount. And you're also going to need the 1/2 inch socket for the removing the motor controller. So there are 2 power leads that are in the back here. There are 2 wiring controls that go back here. One is apparently for the Hall effect sensors for the motor, and the other one is the general control wiring harness that controls things like the beeper, the accelerator pedal, brake switch pedal. All that is apparently fed into this unit here. The other 3 wires, heavy duty wires, go to the motor. These are the power wires for the motor. So the first conundrum I had was removing these 2 small sockets. So these just plug in, and I had a heck of a time trying to figure out how to unhook them. So this white one, let me get you down and zoomed in here. So this white one has a little tab. You push down on the tab and then it pops right out. That one was not so bad. This one here, there is a part up top that's got a little tab on it, but that apparently has nothing to do with removing the socket. The interesting side is the other side here. There's a tab down low, and you actually push this tab outward and then pull down on the bottom half of the socket to pull it out. So that's how this one comes apart. So for all of for the power leads and for the colored leads for the motor, let me pull you back out here a bit again. These will be physically mounted under here. There was a zip tie holding these wires up here. So you kind of, with the battery tray out, you can bring things up, have access to them. It's still a little difficult, but these are shrink wrapped together, and they snap together like this, and there will be a piece of shrink wrap. I have another piece right here that is continuous around the whole thing. So how I managed to remove them is I used my utility knife. I scored along all 4 edges on both sides of this connector in the center. There's a little indentation. You can kind of just follow that indentation. And then I did a score down the center to split it so I could peel it away. And you have to do that for all 3 of these, down for the motor, and the 2 power leads way back in here. So now on to the testing of the motor controller. I found this documentation online. I will hold it up for a moment here so you can read it and study it. Again, I got this off the Facebook group. But the one that I have kind of confirmed without a doubt that the motor controller is bad is this resistance test, the continuity between the heavy yellow, heavy green, and heavy blue wires. So according to this, the resistance is supposed to be around 20k ohms. So I have my multimeter here. This is just a cheap Harbor Freight multimeter. And we're testing resistance between, we're going to go between the yellow and the green. And that, in this case, measures about 18.5 k ohms. But something is going on with this blue lead, because when I test between green and blue, it's kind of climbing, which is interesting. When I test between blue and yellow, it's about 14 k ohms and also climbing. But to prove without a doubt that the motor controller is bad, I don't remember if I mentioned this now, when it wouldn't beep in reverse, but it was also very difficult to push. It was like the motor was stuck in gear. As you can see, I can push this back and forth very easily right now, and I can hook up the green and the yellow, and again, there's no power to this whatsoever. Still pushes very easily. Once I hook up this blue wire, suddenly the motor is engaged. Disconnect that blue wire, it pushes freely again. And this is consistent with me plugging in that blue wire in any order. So I have to have the blue wire plugged in along with something else. So again, the blue by itself is fine. Let's do blue and yellow. Hard to push. Disconnect the yellow. Pushes smoothly. Put the green and the blue together. It's hard to push again. The motor's engaged. So there's something weird going on with this motor controller. And I've heard that these are potted inside, so there's nothing you can do to fix them. You just need to replace them. I have seen people say that you can use an aftermarket controller and program it yourself. That's a little beyond my capabilities, I think. So I am going to look into getting a replacement motor controller for this and pop it in, and I'm hoping the motor will be good to go after that. So again, that's where I'm at with this repair, and I'll be back, I hope, with good news once I get a new motor controller. So we are back to working on my Ryobi riding mower. I got a new drive controller, and I am just going to once again compare the old controller to the new controller for the ohm reading measurement to show you that there is a difference. So I did actually pop open the cover on the old one. This is what it looks like inside. I don't see anything obviously damaged, but there is a lot of potting material in there, hiding all sorts of fun, I'm sure, which is unfortunate, which also makes this unrepairable. But as I think I showed last time, when we tested from green to yellow, we're around 20 k ohms like we're supposed to be, but anything to blue is not. There we go. So 12 to 14. So we're going to test from blue to yellow on the new one. You get almost 20. Blue to green. 20. Green to yellow. 20. That is what we're supposed to have. So let's set this old broken controller aside. And you can see on the side here, it's kind of hard to read. There we go. That YNC 1612, that's the 2016, probably the 2016, 12th month, so December 16th is when this was built. And I'm guessing A0066 is the serial number of this unit. My new unit, built in 2024, 816 and A0115. So we're going to first just plug in the 3 colors down here. Actually, let's see. Maybe we'll mount the controller first, because these go under the battery tray. I'll just stick these in loosely for now. So, yellow, green, and blue. Feed them underneath. And then we will plug them into their corresponding plugs. All right. And we're still able to push the mower with those plugged in. As you recall, with the old ones, or the old unit that was defective, I couldn't really push the mower. So next, I am going to tape up these connections, since we cut the heat shrink off of them. And this will both protect the wires and keep those connectors from working themselves loose. I'm using a yellow electrical tape. It's just what I happen to have handy. then these connectors had been underneath here and they were tied up with a zip tie, so I'm going to do the same thing. If I can get it fed through the... There it goes. Shoot. Zip tie is being finicky. There we go. All right. So then for these other connectors, tape this up a little better. The big wide connector. It goes in like that. We have the white connector. And that goes in like that. Didn't seem like it snapped into place. Snapped in that time. Fold these out of the way of the battery tray. And lastly, we have the power connectors. Alright, everything is tucked up out of the way. And I will bolt down the controller fully. Okay. Next, we are going to, first off, mower still moves, freewheeling at least. Take the battery and heft it into place. Watch and make sure that it doesn't catch on anything. Okay. Let's put the main battery bolt back in place. Make sure the power is off. And we're going to plug it in. covers off for now. Just to test it. And let's see if this blows up another controller or if it just works. Neutral. Turn it on, we got the click. Good sign, we got the reverse beep. Hey, we're moving. Try the blades. I think we're in business. So I'll just throw the covers back on and should be all set to mow another time. Let me see if I can get you a shot of me putting the cover back on here. So the side has to go on first. Work it around to the blade height. And I need to grab my Torx bits. Alright, so there's a screw on the end here. One on top here. Bring you around. One on the top here. Side here. One over down here. There's the 4 on the height adjustment, which you don't need to take off, just making sure they're tight. And we got 4 bolts left, correct. So we'll come back around. Finish putting the back together. Whoops. Our battery tray bolts back in. switched directions here. Alright, and then we have our rear cover. Snaps in on the top. And we have our 4 bolts holding it in. Basically at the 4 corners. Tight. Alright, this mower is ready to rock and roll again. So thanks for watching, everyone.